So in this video we have a partly drawn sketch of this quadratic curve. Y equals x squared take away 6x plus 5. Okay? Now, I've already sketched the shape, the parabola, and I've already identified where it's crossing the x-axis, and that's at 1 and 5. Okay? So, you might be going, well, how have I identified 1 and 5? How do I know that to be the case? Well, part of that is going to come through from something that we're going to look at later on in this section. So you can use the quadratic formula to determine those 2 points. Alternatively, you can factorize the quadratic. So one of the things we've done in a previous section is factorizing. So for this one, if you were looking at this, you could say, well, we need 2 numbers that add together to make -6, but multiply together to make 5, which is -1 and -5. So x take away 1, x take away 5. And then from what we saw in the previous video, if you were to ask, okay, well, where does it cross the x-axis? Well, that is when y is equal to 0. Now, if y is equal to 0, then either this bracket is 0 or this bracket is 0, which means that x would have to be 1 or x would have to be 5. And that gives you the 1 and the 5. And so there is the methods that we have built up to this point we can utilize. But my main focus is making sure that we can identify the important points of the curve from here on out. So based on what we did in the last video, we were looking at the y-intercept, and that was when x was 0. So when x was 0, we would get y is equal to 5. This term would be 0, that term would be 0, y equals 5, and so it goes through 5 on the y-axis. And you can see that because that is the term that we've got at the end. That's our y-intercept. Now, what else is important? What else do we want? Well, 2 things. The first thing is this point here. This point we refer to as a turning point, and so it is the turning point of the parabola. Some people refer to it as the vertex of the parabola as well. When you get to the next level, up to A-level maths, you'll learn about stationary points. And so you can refer to this as a stationary point as well. But for the moment, let's call it a turning point. Okay? So this is a turning point. And we'd be interested to know what the coordinates of that point. Now, we have learnt that parabolas have a line of symmetry. Here it is. Now, could I work out what the equation of that line of symmetry is? Well, yes, I can, because it has to be halfway between 1 and 5. So if I was to find the average of 1 and 5, that would be 1 plus the 5, and then halve it. So 1 plus 5 is 6, divided by 2 is 3. So this is 3 on the x-axis. That means I already know the x-coordinate of that point. It's 3. If I want to know what the y-coordinate is, well, in order to do that, I'm going to have to substitute x is 3 into my equation. So when x is 3, y would be 3 squared, take away 6 times 3 plus 5, which is 9 take away 18 plus 5. 9 take away 18 is minus 9, plus the 5 is minus 4. And so that's minus 4. And so that is the coordinates of the turning point. So this is our turning point. This is our line of symmetry, which has the equation x equals 3. These are the x-intercepts. So there and there. And this one is the y-intercept. Now, just to throw an extra bit of terminology in here, be aware that we also refer to 1 and 5 here as the roots. So the roots of the equation 0 is equal to x squared take away 6x plus 5. Okay, so refer to 1 and 5 as the roots of the quadratic. Quite often that gets used instead of x-intercepts, but really you should be aware of both.